All right, welcome back. Today, we are diving into what I think is one of the most exciting parts of the whole process, phase 4 of the CPMAI methodology, which is all about model development. This is it. This is where all that hard work of data prep and planning finally starts to pay off, and we get to transform it into a real, working, intelligent AI model. Let's get into the build. So, here's what we're going to cover. First, we'll lay the groundwork and define what the build phase is all about. Then, we'll get into the nitty-gritty of how you actually select the right modeling technique. After that, we're going to look at some really powerful ways to accelerate the whole process, and we'll wrap up with the absolutely critical build and optimize loop. So first up, what exactly is this model development phase? Well, think of it this way. After all the meticulous planning and blueprinting, this is where we actually start construction. We're taking our prepared data, our raw materials, and building a functional model from it. And the CPMA workbook puts it perfectly. It says this is the phase where we embark on the creation and development of machine learning models. But, this is so much more than just writing a bit of code. It is the core build activity, and it covers everything from choosing your algorithm right at the start to the final tweaks that optimize its performance. Okay, so we've got our foundation of clean, prepared data ready to go. Now it's time for the assembly. But where do you even begin? Well, it all starts with making a few really smart foundational choices about the tools and the approach you're going to take. And really, the first and most critical step is this: selecting the right modeling technique. I mean, you wouldn't try to build a skyscraper with just a hammer, right? You need the right tool for the job. In AI, that means picking an algorithm that's specifically designed to solve your kind of problem, whether that's prediction, classification, clustering, or something else entirely. And this process isn't just guesswork, it's very structured. First, you pick your algorithm. Second, and listen, this is so important, you document its assumptions about the data you're feeding it. And finally, you set its initial dials, or what we call hyperparameters. Honestly, that second step, documenting the assumptions, is where so many projects get tripped up. So let's talk about these assumptions for a second. Every single algorithm has rules. For instance, a model might assume that your data has no missing values at all. If you feed it incomplete data anyway, it's not just going to underperform, it might completely break. Understanding and respecting these assumptions is, I'm telling you, the difference between a successful project and a failed one. Now, you're going to hear this term hyperparameters thrown around a lot. The easiest way to think of them is as the dials and knobs on your model. You're the one who sets these before the training process even starts, and they basically guide how the model's going to learn. We'll come back to fine-tuning them later, but getting them in the right ballpark from the get-go is key. So, you've chosen your algorithm, you've set your initial dials, now what? How do you make the whole build process more powerful and, let's be honest, faster? Well, let's talk about a couple of incredible accelerators that can supercharge your build. First up are ensemble methods. The idea here is actually really simple. It's all about teamwork. Instead of putting all your faith in just one model, you combine the predictions from several different models. By pooling their collective intelligence, you almost always end up with a much stronger, more robust, and more accurate result. Next, we have AutoML, which stands for Automatic Machine Learning. Think of this as your own personal AI data scientist assistant. It automates all that tedious work of testing dozens of different models and settings, and it can rapidly figure out the best combination for your specific project. This can save you a massive amount of time. And this slide just lays out the difference perfectly. Ensemble methods, they're all about combining models to get better strength and accuracy. AutoML, on the other hand, is about automating the search process to improve speed and efficiency. Both are incredibly powerful tools you can have in your toolkit to accelerate your project. All right, now we get to the real heart of model development, and you need to understand that this is not a straight line. It's an iterative loop. It's a cycle of building, testing, and refining your model over and over again until it's performing exactly how you need it to. The loop always starts here. You take your prepared data, your chosen algorithm, and those initial settings, and you build the very first version of your model. Just think of this as your first draft. It's not going to be perfect, but it's a start. But here's the thing. This step produces so much more than just a model file. The documentation that comes out of it is just as critical. You have to record how the model works, and, crucially, any issues or difficulties you ran into. Trust me, these notes are going to be invaluable for the next time around the loop. Next stop, you have to test it. If training the model is like practicing in the gym, this is the actual competition. You can't just test it on data it's already seen. You have to use a completely separate set of data that it has never encountered before. This is the only way to know how it will actually perform out in the real world, when it really matters. So based on the results from those tests, you go right back to step 1. But this time, you're going to adjust those dials and knobs, the hyperparameters, to try and improve the performance. Maybe you need to increase the learning rate, or maybe change the depth of a decision tree. This is the optimized part of the loop, and it's where the magic really happens. And look, the crucial point here is that this is not a one-and-done process. As the CPMI workbook states directly, you repeat this loop of building, assessing, and tuning until you strongly believe that you have found the best model. It's this constant iterative refinement that separates a decent model from a truly great one. So, there you have it. We've walked through the entire build phase, from selecting your tools and understanding their rules to supercharging the process, and finally, refining everything through that build, test, optimize loop. And that leaves me with just one question for you. Thinking about your own projects, which one of these steps holds the biggest opportunity for you to improve?